Okay, let's continue with the first example. Before we continue with the calculation, this example is just to calculate the value of I, in which that I is moment of inertia. So in chapter 3, in chapter torsion, you have the value of moment of inertia as J, in which that J is polar moment of inertia. But in this chapter, because it is not twisting, we call it as I. So it is not polar, it is moment of inertia. So this moment of inertia is actually means when you try to twist or you give a force to a body or a structure, the structure is actually try to resist the force that you have given. So this is what the moment of inertia means. Okay. Okay. So for this structure, which consists of this beam, calculate the value of I, the moment of inertia I total for this beam. So what is the I total for this structure? So firstly, you divide this whole structure into 3 parts. This is 1, this is 1, and then 2, and then 3. Okay, and then the equation to find the I total is the summation of moment of inertia for the first structure I1, and then you plus with area times distance square from the centroid, and then I2 plus area for this number 2 times with the distance square from the centroid, and also the same I3 plus area times to the distance from the centroid. So first we have to find what is the centroid of this structure. What is the centroid? Okay, in order to find what is D. So this is the equation. So when you get all this value, you sum. So I total is equal to all this. Okay. So okay, so to find the value of moment of inertia for this body, I show in another slide. So this first you have to find the section centroid. So the section centroid can be find using this method. So you have part 1. 1 is the area in mm square, and then the centroid for each part from the vertical direction, and also the centroid times the area. Okay, so for the first part, which is this one, so the area is 38 times 250, and then this area is 25 times 300, and then this area is 38 times 150. So this 38 times 150. So this one is 38 times 250, because this one times this one, because it is the area. So you get this is 38 times 250, so you get 9,500 and then for part number 2 you get 25 times 300 300 equal to 7500, and then you got number 3, 38 times 150 equal to 5700. So the y is 38 plus 300 plus 38 over 2. So this one you get 354. So this actually, because this is the first part, so you want to find the centroid for this part, for the first part. So the centroid will be in the middle of this part. So this one you need to divide by 2. So this one is 38 over 2 because it is in the middle of this. And then you have to sum, you have to add with 25 and you have to add with 38. So the centroid for the first part is equal to 38 plus 25 plus 38 over 2. 38 plus 25 plus 38 over 2. And then for the centroid for the second section is in the middle of this. So this is 300, it must be 300 over 2, and then plus with 38. So this one is 38 plus 300 over 2. Okay. And then similarly, for the section centroid of the third part, it is in the middle of this, so it's 38 over 2. Okay, so this one is 38 plus 300 over 2, so it's equal to 188, and this one is 38 over 2 is equal to 16. So this one we move to here. Okay, so this is y centroid, y times area, we got m to the power of 3. Okay, so this area times with the section centroid, so this one is 9500 times 354, you get 3363000, and then similarly this one is 7500 times 188, you get 1410000. This one is 5700 times 16, you get 91200. And then the sum of all this area, you get 22700, and then the sum of this you get 486420. Okay, so the centroid for the whole structure is the summation of centroid is each centroid times area over the whole area, so you get 486420 over 22700, and then you get 214.3. So the section centroid is actually probably here, so 38 plus so probably here, around here. Okay, okay, so now you already have the centroid for the whole structure, and then start finding the value of I. We want to find the value of I. So from the equation, I total is equal to the summation of I plus AID square. So for the first I number 1, which is this section, so the equation is I1 plus A1D square. So this is 1 over 12 BH to the power of 3 plus area times distance of the centroid compared to the this centroid to the whole structure. So it is equal to 1 over 12 times B 250 times H 38. You look at this value by referring to this structure. So this is 38, which is the H, and this is the B 250. Okay, and then plus area is this one 9,500 times the distance from centroid for this section to the centroid of this whole body. So you get, actually this one is 38 plus 300 over 2 minus plus 38. No, this is not 38 plus 300 plus 38 over 2 minus 214.3, and then this has to be square because we have this square, and then you calculate using calculator. So 38 plus 300 plus 38 over 2 minus 214.3. Or if you want to use this, also can, this one. So this is actually, if you don't want to write like this, you can use this 354 minus 214.3. So you get this is equal to 1,211,908,667. So you use you try to calculate, okay, and then find I2. I2 is equal to I2 plus A2D square. So I2 is 1 over 12 BH to the power of 3. So in this case, I2 is, this is 25, B, H is 300, 3 to the power of 3, area is 7,500, and then D, okay, so this is, and then times D is 188, this is 188 minus 214.3 square. So you get this 61437675, and then you calculate the same thing for I3. You got the answer, and then the I total is I1 plus I2 plus I3, and then the final answer is 149,144,2155 mm to the power of 4. So this is the final answer for the moment of inertia for this structure.